So we're going to take a look at 4 different word problems for the homework for tonight. Our first one is Georgia wants to evenly divide 84 trading cards among 6 friends. How many cards will each friend get? So the first thing we do when we read a word problem is just think about, what is it talking about? Well, I know it's talking about trading cards, so now I have the topic in my head. So the second time that I read it, I'm thinking about what are the important numbers that pop out to me. Georgia wants to evenly divide 84 trading cards among 6 friends. How many cards will each friend get? And not only the numbers, but also this word popped out to me to show me what I needed to do as well. All right, for our third read, you really want to see, well, what does the question want me to do? What is the question really asking for? Georgia wants to evenly divide 84 trading cards among 6 friends. How many cards will each friend get? So really what I'm wanting to know is how many of those cards will every friend get? So I have to evenly divide 84 by 6. So let's go and take a look. So in our setup, we always have our bigger number in the middle, smaller number that we're dividing by on the outside. So can 6 fit inside of 8? And it can. How many times can 6 fit inside of 8? I agree, it'll be once. So now, after we've done our division step, we do our multiplication step. So what would 6 times 1 get me? That's exactly right, it gave me 6. So now we've done our division step, we've seen how many times can 6 go inside of 8, and that was once, that's why I got our 1 up there. Then we did our multiplication step, 6 times 1, which got us our 6 down here, and now we go ahead and do our subtraction step. So let's do 8 minus 6, which would give me 2. All right, now we gotta ask ourselves, can 6 go inside of 2? And it can't. So what do? That's exactly right, we bring down that 4. So now we're seeing how many times can 6 go inside of 24? And if we skip count up, 6, 12, 18, 24, so go in there 4 times. All right, now that's our division step. We've done how many times can 6 fit inside of 24. That's why our 4 has gone up here. Now we're doing a multiplication step. 6 times 4 would get us what? That's exactly right. It'd get us 24. And then we go ahead and do our subtraction step. So it always goes division, multiply, subtract, and check. Divide, multiply, subtract, and check. Every single time. So now we're on our subtract step, 4 minus 4, that gets us 0, 2 minus 2, that gets us 0, and now we're on our check step. Can 6 fit inside of 0? And no, it can't. Is there anything left that we could bring down? I agree, there's not. So 14 is our answer. And we really want to label this, so we wouldn't just put 14, we would say each friend gets 14 cards. All right, let's go and check out our next problem. This one says Ryan has 9 14-ounce bags of popcorn to repackage and sell at the school fair. A small bag holds 3 ounces. How many small bags can he make? Okay, so the first thing we're thinking about when we read through our problem is just what is it talking about? Well, I know that Ryan's selling some popcorn, and I know that there's different size bags of popcorn. Okay, the second time that we read, we're looking for those important numbers. So Ryan has 9 14-ounce bags of popcorn, so that's how much he starts with, to repackage and sell at the school fair. A small bag holds 3 ounces. How many small bags can he make? So I know that he has 9 14-ounce bags already, and I know that he wants to repackage those into smaller bags. And so those could be 3 ounces. All right, so the last read is just what does it want us to do? So I'm gonna put a different color here. Ryan has 9 14-ounce bags of popcorn to repackage to sell at the school fair. A small bag holds 3 ounces. How many small bags can he make? So we're trying to find out how many small bags is he able to make with those big bags. So the first question we have to answer, this is multi-step one, we have to figure out how many ounces of popcorn does he have in all. So what we're sitting with here is, we know he has 9 and they're all 14 ounces. So what could we use to go ahead and figure that out? That's true, we could do addition. It could look like this, we could go 14 plus 14 plus 14, so on and so forth, all the way through. And that would work, but that would be pretty darn slow. Instead of doing that, we could do multiplication, which is really just repeated addition. So let's go ahead and stack 14 times 9. That way we can see what the actual amount is. So first I have my 4 times my 9, which will get me 36. So I gotta regroup, put my 3 up here, bring my 6 on down. Now I'm gonna do 9 times 1, which would get me 9, that's right, but we have to add on our 3. So now we got 9 plus 3. So think 9, 10, 11, 12. And then we have nowhere else to regroup over here, so the 12 just comes right down. So we have 126 ounces that we're working with to start. All right, so let's go to switch colors. So now we know that Ryan has 126 ounces. And thinking back to our question, he wants to make them in small bags. How much can a small bag hold? That's exactly right, 3 ounces. So we're gonna take 126 and 3, and what are we gonna do? Divide, multiply, subtract. That's exactly right, we're gonna divide. So let's go ahead and put 126 and divide by 3. All right, can 3 fit inside of 1? I agree, it can't, it's too small. So now we're fitting 3 inside of 12. How many times can 3 go inside of 12? That's exactly right, 4 times. All right, that's our divide step. How many times can 3 go inside of 12? So that's where we got our 4. Next, we do our multiply step. 3 times 4, and I agree that would also get us 12. And now we do our subtraction step. So remember, it always goes divide, multiply, and subtract, and then we go ahead and bring it on down, bring it on back, do the check. So now we're at our subtraction step, 2 minus 2, that would get us 0. 1 minus 1, that would get us 0. Can 3 fit inside of 0? I agree it can't, it's too small, right? So what do? 100% agree, we bring down that 6. So now we're looking at, can 3 go inside of 6? I agree, it can, but how many times can it go inside of 6? That's right, I would do 2 as well. So we put our 2 on top, that's from our divide step. How many times can 3 go inside of 6? That's where we got that 2 from. Now we're doing our multiply step, 3 times 2, which I agree would get us 6. And then we do our subtraction step, and 6 minus 6 would get us 0. Now we do our check. Can 3 fit inside of 0? And we know it can't. Is there anything else that we can do? Anything we can bring down? I agree. So again, when we finish this problem, we really want to label it. We don't just want to write 42. So we'd write 42 small bags, because the question we were answering was how many small bags can he make? Alrighty, let's check out our next one. Toby has 62 guests coming for his party. Each table can hold 5 people. How many tables will Toby need for the party? Okay, so that my first read of a word problem is just me thinking about, what are we talking about? Well, I know that we got Toby here and he's having a party. Okay, so now I got my topic in mind. I'm gonna reread again, looking for important numbers or words that stick out to me. Toby has 62 guests coming for his party, so I'm having 62 jump out at me. Each table can hold 5 people, seems important. How many tables will Toby need for his party? So the 2 things that really popped out to me as important were that 62 guests and 5 people at each table. All right, let's read one more time, trying to figure out what is the question really asking us to do. Toby has 62 guests coming for his party. Each table can hold 5 people. How many tables will Toby need for the party? Really what we want to know is how many tables does he need? So let's go ahead and take our 62 divided by 5, because we know that he has 62 total people coming, and we know that each table can hold 5 people. So if we take the total number of people divided by the number that can fit at one table, it'll tell us how many tables we need. All right, so first thing we look at, can 5 fit into 6? I agree it can, and I also agree it can go in there 1 time. So we put our 1 on top, and again, that comes from our divide step, because we thought, how many times can 5 fit inside of 6? And it'd be 1. Now we do our multiply step, 5 times 1, and I agree that would get us 5. So we've done our divide step, we've done our multiply step, now we're gonna go ahead and do our subtraction step. 6 minus 5. So what would we get if we took 6 minus 5? I agree, that would get us 1. Can 5 fit inside of 1? I agree it can't, right? So we gotta bring down that 2. Now we're thinking, can 5 fit inside of 12? And it can, I'm with you. How many times can it fit inside of 12? I agree it can be twice. So now we gotta do our multiplication step. 5 times 2, and I agree that would get us 10. Now we're doing 2 minus 0, which will get us 2. And 1 minus 1, which will get us 0. So now we're left with our check. Can 5 fit inside of 2? Yeah, I agree, it's too small, right? But is there anything else that we can bring down? Yeah, I agree, there's nothing over here. So we're left with, we have this number that's left over. That would be called the remainder. And since there's nothing else that we can bring down, and we're not jumping into decimals and all that jazz just quite yet, we'll do that in a later unit, we go ahead and just put a little r for remainder, as in a leftover, and then a 2. So we have 12 remainder 2. But let's think about our word problem, because really you have to come at it thinking about what would make sense for the word problem. Because this is the correct answer, but we haven't really finished the question yet. We've gotten the division part correct, but we haven't answered our question. So let's think back. What does our question want to know? How many tables will Toby need for the party? So you have two options here. You could really go for you need 12 tables, or you could go for you need 13 tables. Go ahead and take about 10 seconds and think about, does it make more sense that Toby needs 12 tables or that Toby needs 13 tables? I agree, he needs 13 tables. Because if we think about it, what would we do with those extra 2 people? Are they just gonna sit on the ground? They have to stand? That wouldn't really make sense, would it? So in the context of our word problem, we know that this remainder matters. So when we answer a question, it'll actually be 13 tables. That's why it's super important to do your 3-read step on word problems, because it really will change. Sometimes your remainder matters and sometimes it doesn't. It really depends on what the word problem is asking you to do. All right, let's go and take a look at our last problem. Bianca is making scarves to sell. She has 33 pieces of blue fabric, 37 pieces of green fabric, and 41 pieces of red fabric. Suppose Bianca uses 3 pieces of fabric to make 1 scarf. How many scarves could she make? All right, the first thing that's popping out to me is there's a lot of stuff going on here. So I'm gonna be really careful in my 3-read strategy. But my first read has told me that I know Bianca is making scarves. That's what I can take away so far. All right, my second read, I'm looking for those important numbers that pop out to me. Bianca is making scarves to sell. She has 33 pieces of blue fabric, 37 pieces of green fabric, and 41 pieces of red fabric. Suppose Bianca uses 3 pieces of fabric to make 1 scarf. How many scarves could she make? Okay. And now in my third read, I'm trying to figure out, what is it asking me to do? What does it want me to do? Bianca is making scarves to sell. She has 33 pieces of blue fabric, 37 pieces of green fabric, and 41 pieces of red fabric. Suppose Bianca uses 3 pieces of fabric to make 1 scarf. How many scarves could she make? So really the question that we want to know is, how many scarves can she make if she has all this stuff? And so it doesn't tell us any specifics about we have to use certain pieces of color or anything like that. We just have to know the total number of pieces of fabric that she has. So how could we figure out the total number of pieces of fabric? I agree, we go ahead and add them together. So let's take 33 plus 37 plus 41. All right, so as I'm adding these together, I'm thinking, is there a strategy I can use to make my adding easier? So what pops out to me is 3 and 7, I know that makes 10, so I'm gonna go and add these real quick, 10, and I got 10 plus 1, which would give me 11. So I do have to regroup. So one's gonna go up here, and one's gonna come down here. Now I'm looking at this, and it gets a little bit trickier, but I can see that 3 plus 4 would make me 7, and then I know that 7 plus 3 makes me 10. So I know that these 3 numbers together would add up to be 10, and then I have 1 on top. So now I got 10 plus 1, which would give me 11. So I know that Bianca has 111 pieces of fabric. But the question is, how many scarves can she make, not how much fabric does she have? So we have to think about, how can we take the total number of pieces of fabric and turn that into how many scarves she makes? Well, I guess that really depends on how many pieces does she need for 1 scarf. Let's go and take a second look back on our question. How many pieces does she need to make 1 scarf? I agree, it would be 3. So what if we take our total number and divide it by 3? That should tell us how many pieces she needs, or how many scarves she can make, rather. All right, so let's take 111 and divide it by 3. All right, how many times can 3 fit inside of 1? I agree, it's gonna be 0, it's too small. So let's look at how many times can 3 fit inside of 11. Yep, I agree, that would be 3, because we'd go 3, 6, and 9. 12 would be a little bit too high, so we can't do 4. So we're gonna have to stay at 3. All right, that's our divide step. How many times can 3 fit inside 11? We decided 3. Now we're gonna do our, that's right, multiply step next. 3 times 3, and that would get us 9, you're exactly right. Now looking at it, I can't take 9 away from 1, so I know that I'm gonna have to go ahead and borrow here. So I'm gonna steal 10 out of here and give it to my 1. So now I have 11 minus 9, which I could count down, but a quicker way would actually be to count up. So if I go 9, 10, 11, it would give me 2. And then 0 minus 0, that would give me 0. So now, can 3 fit inside of 2? I agree, it can't, right? It's too small, it wouldn't work. But what can we do? Because I don't think we're done yet. Yeah, I agree, we bring down that 1. All right, so now looking at it, how many times can 3 fit inside of 21? I agree, it would be 7. So now we've done our divide step. How many times can 3 fit inside of 21? We decided that was 7. Now we're doing our multiply step, 3 times 7. And I agree that would also be 21. Now, after we've done our divide step and our multiply step, what comes next? That's exactly right, that's subtraction step. So now we got 1 minus 1, and that'll go ahead and get us 0. And now we got 2 minus 2, and that'll go ahead and get us 0 as well. So now we do our check. Can 3 fit inside of 0? And I agree it can. Do we have anything else that we can bring down? I agree, we don't. So we are left at 37. But remember, we got to label. We can't just put 37. So how can we label this? Go and take a couple seconds, look back at our question. And when I'm saying look back at the question, really what I'm saying, usually looking at the end, not always, but most of the time. How many scarves could she make? So we ended up with 37, but 37 is not really our answer. 37 what? 37 gorillas, 37 monkeys, 37 people. I agree it's scarves. So let's go ahead and make sure that we label scarves. All right, thank you guys for tuning in. Appreciate you. See you guys on Monday.